Hi everyone. We're going to take a look today at some of the concepts from the guided notes. We're going to take a look at some examples, and I'm going to use the survey that y'all just completed as the basis for our examples. The first thing I'm going to do is to go to the StatCrunch website. And I've uploaded the results of our student survey. It's under my data. I'll have to check with y'all to see if you have access to that or if I have to put it in a different place. So I made an Excel sheet of the survey data. I'm going to click on that now, and it should just open up into StatCrunch. Okay. So a lot of what we were doing in the guided notes was sorting out some terminology, definitions of vocabulary, and so on. So I want to take a few minutes to kind of go through how those terms apply to the data set here. So the first thing is a lot of statistical data sets are organized in this way, where the rows, right, as I go down the rows here, these represent the individuals in the study. So each one of these numbers represents one of you who completed the survey. You can see that we got 29 responses, which is pretty good out of 32. I was hoping for all 32, but we got 29. So the individuals are the things we're interested in studying or collecting data about. And in this case, they're BSc students, they're you, but they don't have to be people. Okay, so individuals can be cars or hospitals, really anything that you would like to collect data about. Now, across the columns is where we store our variables. So the variable is a characteristic of an individual, and basically all of those questions that you are asked in the study generate variables for us. So we have sex, political affiliation, whether or not someone smokes cigarettes, the number of alcoholic beverages someone consumes in a typical week, whether they have a credit card, whether they have a checking account, and so on. Now I've abbreviated in order to fit the names, in order to fit the questions into the columns in a reasonable way, and so that they have sort of reasonable variable names. So every column represents a different variable, and we've got lots of them. I want to say a little bit about the ones at the end here. So you might remember one of the questions was to select all of the different kinds of things that are in your diet. So that was fruits and vegetables, dairy products, eggs, wheat, seafood, poultry, and red meat. Now, the way that was formatted when it came out of Moodle presented problems for StatCrunch. I couldn't get it to load the data set correctly. And so what I did was I split that question up into lots of yes or no questions, so that we have a column that represents do you eat fruits and vegetables, and every student got recorded with a yes or a no depending on how they answered the diet question. Similarly, if we go over to the wheat column, this is just yes or no whether someone indicated they eat wheat products or not. So we have a couple of yeses, then a no, yeses, and a no, and so on. All right, so that's what the data set that got generated from our study looks like. I'll go back over to the top left corner for a moment. So we have these variables, and now I'll remind you that variables come in different kinds. We can have what are called categorical variables, and those are the ones that divide our individuals into groups or categories. So Really common one is sex, right? So all the students are divided into categories, either female or male. Political affiliation is another categorical variable because folks are slotted into being Republican, Democrat, Independent, or none. Whether or not someone smokes cigarettes is also a categorical variable because that's a yes or no category. And now, number of alcoholic beverages consumed in a typical week. This is our first quantitative variable, right? So a quantitative variable, it has a number associated with it, and also it makes sense to do numerical calculations on those numbers. So I'm just going to kind of go through the next several, see if you can kind of predict before I get to them. Credit card, is that categorical or numeric? Or I guess I should say categorical or quantitative. That's a categorical variable because it's just a yes or no. Whether or not someone has a checking account, also categorical. How many hours of sleep someone got the previous night or in a typical school night, that's going to be a quantitative variable. And now we'll talk a little bit about the difference so there are kinds of quantitative variables too. Remember, there are either continuous or discrete. So a discrete quantitative variable requires numbers that come, values that come from a set of separate numbers. So typically a way to think about that is, does it make sense to have half of one of them? If the answer is no, then it's a discrete variable. If the answer is yes, then you're sort of safe in thinking it's going to be a continuous variable, one where the values can take an entire range of numbers, not just a specific list of numbers. So hours of sleep here, it looks like everyone reported whole numbers, but hours of sleep, of course, could be, it makes sense to talk about a half hour of sleep or 0.1 hours of sleep. So hours of sleep is quantitative, but would be continuous. The number of texts in the last 24 hours, I guess we could fuss about this a little bit. You can't really send half a text, so we would call this one a discrete variable, right? You only have whole numbers of texts that have actually been sent. The time that someone sent their last text last night, this could be continuous, right? Time is continuous, just depending on how fine you wanted to measure it. Actually, this reminds me that I wanted to say something about this variable because I recognized after the survey that the way the numbers were getting reported was going to be inconvenient for the way, that we want to deal with this variable later on, right? So it's not necessarily going to be a problem today, but later on it would be. And the issue is that, right, if somebody recorded 10 o'clock at night, like say student 3 as the last text, and then we compare that with someone who sent their last text at 1:30, then that person responded 1.5, which makes it seem like a lower number than 10 o'clock, even though it was later. And so the way I decided to address that issue is that if someone entered a value that was after midnight, I added 12 to it. So it made a reasonable comparison with the other times. So that this person number 4 actually entered 1:30 or 1.5 as the time of their last text. Now I've made it into a 13.5. So that then is a later value than, say, 12 midnight. Right? Let's see. So people texted, that's going to have to be discrete. Let's see. I think that's enough to get the picture for discrete and continuous, and quantitative and categorical. All right. So let's take a look at some of the graphing capabilities for StatCrunch. Okay, so we have graphs that are typically good for categorical variables are pie charts, bar charts, and then what are called Pareto charts. Pareto is really just a bar chart, but the bars are in numerical order, from biggest to smallest, or from smallest to biggest. So let's take our first variable and do our first graph. So we're just going to see how the distribution of respondents is among the male-female category. So I went to graph first. Right, so graph, I'm going to select a pie chart because I'm dealing with a categorical variable, so that makes sense. And then with data, it just tells it to look in the column I'm going to tell it for the data. Right, I'm interested in how the sex breakdown turned out. And so I just need to tell it that's where the data lives, in that column. And then I'll hit compute. And it looks like we got a roughly even spread. All right, so I'll point out a couple of things that appear on the chart. Let me move this so it's centered. So a couple of the terms that were in the guided notes, one was frequency. That's the number of times a variable occurs. So the number of female respondents was 15. So that's the frequency for females in our sample. The number of males was 14. Right? So that is the frequency of males in the sample. And then the relative frequency is either the percent or proportion. They both tell us the same information, so either one is okay. And this is just pointing out that 15 out of 29 is 51.72%, and 14 out of 29 is 48.28%. Notice the percentages add to 100, so we have all of our data here. And we've got which category, the frequency, the relative frequency, and then a graphical depiction where you can see the female category is slightly bigger than the male category, reflecting that there are slightly more females in the sample than males. Let's look at another one. So political affiliation. If I go to graph, pie chart with data, and select political affiliation, then we get, again, a list of all the categories, Democrat, Independent, None, or Republican, and then the frequencies and relative frequencies for each. 14 Democrats in the sample, that's 48.28%. One person identified as independent, 3.45%. Two had no identification. And then there were 12 who identified as Republicans at 41.38% for the relative frequency. Something that I think we have a smallish sample, but I still thought it was a little interesting to take a look at, is if you go to Options and Edit, then you can tell it how you want it to change. And one thing that you will do a lot of is you'll group your respondents by some other categorical variable first. So I'm going to group by sex. And what this is going to tell us is the political affiliation distribution of males and females separately. So you might spend a moment to think what you might expect. Will males be more Republican than females, or will females be more Republican than males? So that's what this question, that's the question that this example might answer. So I'll hit compute and drag this to the center. And we see that for females, overwhelming majority, 73.3%, identified as Democrat, 26.7% identified as Republican. And if I click this arrow button, I'll cycle through to the male version. So here's the male breakdown. Here we have a majority Republican, about 57%, 21% Democrat, and then the independent and 2 unaffiliated were males in this sample. So it's a smallish sample. We don't want to get too carried away with making broad generalizations, but it appears that our sample provides some evidence that at least among BSc students, females are more likely to be Democrat than Republican, and more likely than males to be Democrat. All right, let's take a look at a bar graph also. So maybe we'll go over to the religious services question. So this was how often someone attends an organized religious service. And this is a categorical variable. And so we can do a bar graph. So bar plot with data. So let me go to religious services and compute. So we get, this is a little hard to read. I'm going to blow it up if I can. Still, I wish the font was a little bit bigger, and that's probably an option that I can control, but let's take a look at what this bar graph is showing us. So it's got the categories across the x-axis, and then the frequency or counts along the y-axis. So the number of folks, for example, who reported never attending religious services, I'm just hovering over the bar and it pops up and tells me the frequency is 4. If I hover over the largest bar, it looks like the most common response was folks occasionally but less than monthly were attending religious services. 11 of you said that. And then we had a tie at 7 for at least monthly but less than weekly, and at least weekly. All right, so this is a bar graph. If the bars were ordered in increasing or decreasing order, then we would consider it a Pareto chart instead of just a bar chart. Now, let's look at options. And let's see if there's any difference among males and females for this one as well. So I'm going to group by sex again. And then what we get is a side-by-side bar chart where we get the counts for females in blue and males in red. And it looks like, let's see, for the never attending, 1 male said as much, and 3 females did. So it, again, a small sample, but some indication that we have more females or females at BSc are more likely to not attend services than males. The category for occasionally but less than monthly is really close. 5 for females, 6 for males, so no particular difference there. And these two seem kind of flipped, right, where we've got at least monthly but less than weekly. You've got more males responding that way than females, but at least weekly, so more than once a week, we have many more females responding than males. So it actually looks like females might be sort of more likely to be at the extremes here, where there are more that say they never attend, but also more that say they attend at least weekly. One thing you can do in StatCrunch is if you hover over one of the bars and then click on it, it'll highlight all of the respondents that led to that result. Right, so if you're curious about some other particular aspect of one of those folks, you can go in and take a look. So let me get out of that. Looks like those are going to stay highlighted for a bit. All right, so we've taken a look at bar charts, pie charts. Now we're going to take a look at some of the quantitative variable graphs. So let's go to, say, a dot plot, and maybe we'll do hours of sleep for this one. So this one, I think you'll notice something kind of interesting about it. So like we got leaf blowers next door. I hope that's not going to disrupt things too much. All right, so we've got hours of sleep, and we can make our dot plot. I'm going to make this a lot bigger. So this dot plot is showing us the distribution of the reported hours of sleep during a typical school night. And so over here, right on the left-hand side, we have most of the data. And I want you to think about these two values way over here to the right. Right, so this would be a really obvious example of a couple of outliers. And when I went back and looked at the wording of the question, I think I understand how these came to be. Right, so clearly no one sleeps 30 hours a night, or 40, what was that, 45? 42 hours a night. And so what I think was happening is because the word week appeared in the question, if you weren't reading carefully, then you took that to be hours of sleep per week. And so when something like that happens, right, for one thing, a graph is really good at showing you where some sort of weird data might be, and then it's up to you to figure out what to do with it. So what I think we should do is just divide those by 7 and get what should be a reasonable daily value for the hours of sleep. But you could probably argue, because I said school week in the example, that maybe we should divide by 5. But I think I'm content to just divide by the 7, and let's see if we can find them. So here's the 42 hours of sleep divided by 7 would be 6 hours of sleep. And then 30 hours of sleep. Let me get my calculator to help me with that one. So 30 divided by 7 is about 4.3 hours of sleep. So I'm going to go back to the box plot, or sorry, the dot plot, which is in my results. I can pull it back up. And now I'm going to refresh it to get rid of those outliers. All right, so now we see a little bit clearer picture of how hours of sleep are typically distributed. Each of these dots represents an observation or a student who reported that number. So we had one student report 2 hours of sleep, one reported 4 hours of sleep, one is the 4.3 that we just calculated. And then we can see that for 6 hours of sleep, we had the most responses. So 1, 2, 3, 4, 5, 6, 7, 8, maybe 8 or 9. And that, because it is the most common response, is referred to as the mode. Right? And it's possible to have more than one mode, but the mode in hours of sleep for the BSc students in our sample was 6 hours. All right, so that's a dot plot. What about a stem and leaf plot? So let's go to the stem and leaf, and let's maybe look at texts this time. So texts in the last 24 hours. So let me center this, blow it up a little. All right, so each of the stems appear on the left. That's the beginning of the numbers. And the leaves up here on the right, that's the end of the numbers, and it will automatically kind of decide for you how to do the splitting. So a 0 and a 4 up at the top here would represent someone who reported sending 4 texts in the last 24 hours. A 0 and a 7 would be 7 texts. If I jump down here, a 10 and a 0 would be 100 texts. And then it looks like these 3 observations were considered outliers. They were much, much higher than the rest. So we had a student report 150 texts, 200 texts, and someone sent 300 texts in the last 24 hours. A lot of text. So the stem and leaf plot here has been split. This is called a split stem plot. And it does this automatically when it thinks it gives you a better picture. So oftentimes you would just have 1, 0, 1, 1, 1, 2, 1, 3, and so on. And then you would have, for the 3, for example, anything that was a 30 through 39 would appear. If we look at the 2s, though, we had a bunch of 20s and we had a bunch of 25s. And with the split stem, maybe we see the sort of overall pattern a little bit better. So the first 2 would capture all of the 20s through 24. The second 2 captures all 25s to 29s. So that's how the split works. You can kind of see it better maybe with the 0. So anything that would be 0 through 4 texts would be counted there, and then anything that was 5 through 9 is counted in the second 0. So we had students that reported 7, 8, 8, and 9 texts there. You can also pick out the modes here. It's maybe a little easier to see than, it's not always easy to see in a stem plot, but looks like we have 5 20s and 5 30s. Right? So those were both modes for the number of texts. All right, so one good thing about a stem and leaf plot is that it shows you kind of the shape of the data, how it's distributed, but it also allows you to recover all of the data just from looking at the picture, right? So you know there was a 4, a 7, an 8, an 8, a 15, and so on. So nothing is lost when you do a stem and leaf plot. All right, what about a histogram? So this is like a bar chart, but it's for quantitative variables. And we're going to do texts again. It's done so that, I'm trying to get rid of that color, and I'm not having a lot of luck. So I guess I'm just going to color it all in. All right, so there we go. Sorry about that. So the histogram forms what are called bins along the x-axis. So you see the first bin goes from 0 to 50. And what this is going to do is collect all of the students who reported between 0 and 50 texts and count how many there were. So if I hover over this, I see that there were 22 students that reported between 0, I should say bigger than or equal to 0, and strictly less than 50 texts. The number of students who sent between 50 and 100 texts was 2, and the rest of these are singles. 1 between 100 and 150, 1, 1, and 1. So if you were making a histogram by hand, it's actually a little bit of a pain because you have to figure out how to do the bins, right? So how big should you make these categories down here? Should you do between 0 and 10, 10 and 20, 20 and 30, and so on? Or between 0 and 100, 100 and 200? And unfortunately, there's not a right or wrong answer. There are just more or less informative histograms. So generally speaking, StatCrunch will make a good choice for you. So if you're doing a histogram, then StatCrunch is typically going to be pretty good. There'll be a couple of questions, I think, in the homework about a histogram that's too coarse, which just means you didn't have enough bins, so it was hard to see what the distribution looked like, or too fine, where you have too many bins, and so it also makes it hard to see the patterns in the data. This one's pretty good, right? So we can see that most students sent between 0 and 50 texts, and then it falls off really quickly, so that we end up with kind of a long tail to the right. So looking at this distribution, we would say this one was right skewed. All right. So we've gone over a few of the different kinds of graphs. For categorical variables, when we put folks in, or put our subjects or individuals into groups or categories. Pie chart is a big one, bar chart, and then if you order the bar chart, you get a Pareto chart. For quantitative variables, we have dot plots, stem and leaf plots, and histograms. Histograms are good for showing kind of the overall distribution. Stem and leaf plots also show you that and have the advantage of being able to determine the exact values of the data from the stem and leaf, where you can't do that from the histogram. Histogram's advantage is that a stem and leaf plot quickly gets unreadable when you have a lot of data, in which case the histogram is definitely the way to go. Now, our data set here isn't so huge that we could do a stem and leaf plot and get kind of a reasonable looking graph, but in general, you'll see histograms a lot. All right, so that's going to conclude this first presentation. When we meet next, we will have problems that you've been working on, both the worksheet and the homework. And I imagine you will have some questions, and we'll get those answered in class. So I look forward to seeing you then. Thank you.